oops, too far. I give you exactly this formula that Hamiltonian. And this term that appears, by the way, I forgot to mention, there's a constant here, which comes from all the terms in the Hartree-Fock equation for the frozen orbitals. That's a constant, so in some sense it's irrelevant. This term can be regarded as is a pseudopotential. And in fact, the pseudopotential approximation is just an extra layer of approximation on the frozen core approximation. You're simply saying, rather than taking this very non-local pseudopotential, I'm going to replace it with something simpler. But so that part of it is formally identical. The only thing we enforce is you have to enforce that the active space is exactly orthogonal to the inactive space, and that's what you do in the frozen core approximation. You're active, yeah.
And so also the inactive space you don't allow it to screen the interactions in the active space.
Not yet, but one could imagine a feedback, and there are embedding schemes where you allow feedback. You allow the many-body calculation to feedback and adjust the embedding calculation. So one could do that.
So 3 orders of magnitude sounds fantastic. Can you give us a feeling of how costly simulation is?
These calculations are very expensive. I don't have absolute numbers, but I mean, we did some of these calculations for the cobalt on the, these calculations we used for, it was actually a rather sort of several steps in doing this calculation. Instead of graphene, we used a chlorine molecule, which has a graphitic type structure. And then we made corrections using density functional theory for the corrections between the chlorine and the infinite graphene sheet. Those calculations burned up, the scale was millions of hours on a supercomputer because we were including so many states from the substrate and the thing. So quantum Monte Carlo is very expensive.
And now you are down. This is already with the.
This is on a desktop workstation with 32 nodes or something, 32 cores.
But here you were already using the trick of the frozen.
Yes, except in these where we could afford to do the full calculation for some of these test systems. Like we could afford to do the calculation for this Oxygen H20, you can do that on a workstation, or on a short chain of carbon, using a modest but accurate quantum chemistry Gaussian type basis.
Okay, let's start to speak again.